Right. Good morning, my dear students. Welcome to the session on cables and suspension bridges, Unit 3 of your syllabus. So, last session we have talked about this cable subjected to concentrated loads, how you plan for analysis, means how you find geometry of the cable as well as the force unknowns, which means both internal forces and external forces. Okay, so support reactions, the other way, you can call them support reactions, and also the cable tension values. Okay, so that is what is discussed. And now let us see one example how you really solve the problem with the planning that we have done in the last session. Okay, so let us see the problem. So determine reaction components at A and B, that means VAHA and VBHB, or else any other name that you can put it. So tension in the cable, which means in the entire cable, where it, after you apply the point loads, the cable becomes segments. Okay, so in each segment you will have a tension value, so you have to find that. And sag y at B and y at E, sag or dip, okay, of the cable shown in figure. Okay, but though there are three sag values, one sag value is given. Okay, so that is what is the uh, one extra data that is required, one extra information, because number of unknowns now we will count, and let us come to know. So neglect sulfate of the cable is already an assumption. So right. Now count the unknowns. So two at A, two at E. So total four. Uh, sag or dip value at B1 and at D another one. So two. One is given. Okay. So 4 plus 2, 6. Okay. Got it? And plus the segments you can count one, two, three, four segments. So plus four tension values. So total 10 unknown values you have to solve. Right. If this is not given, so YC also will become unknown, and that will become 11. So now you count the equilibrium equations. Joint A, one equation. Similarly, joint B and joint C, D and E. Okay. So 1, 2, 3, 4, 5 into 2. Each joint you can write two equations, sigma fx0, sigma fy0. So 5 into 2, 10 equations. So you are able to solve this problem without any additional equation, just with this one given data. Okay, right. So this is how we plan before you start analysis. Okay, right. Now let us see how we start really when it comes to solving, uh, where to start and how to proceed. All this is very important. Okay, so now let us see the problem. So there is a cable with 3 point loads, 17 kilonewton at B, 10 kilonewton at C, and 10 kilonewton at D. Okay, and the span you can see total is 7 plus 7. 14 meters is the span of the cable, out of which the 7 meters to the left and 7 meters to the right, from midpoint. So at the sag or dip at the midpoint is 2 meters is given. So YC I can call it. So that is the information given, right? 3 point loads given, and each segment span is given, and one sag value is given. Okay. Right. So now let us start by applying sigma fx0. That's the first equation to apply. Okay. So sigma fx is equal to 0. So total cable free body diagram. This is cable free body diagram. Because support A is removed, reactions are applied. Support E removed, reactions are applied. Okay. Now you can see the reactions here. This is towards right. This is upward. Okay. Right. So this is how it is. Right. Similarly, say at A also. Okay. Sigma fx 0. So if I say this is horizontal reaction HA towards left minus HB is equal to 0. No other horizontal force is available. So HA is equal to HB. Okay, so that's why we can write it as H. Okay, reason there is no horizontal force anywhere, only two horizontal forces, one at A and another at E. Sorry, I wrote P. Okay, so it is E. Support is taken as E. Okay, done. Right. So what next? And that is written in a sentence here. That's why I have shown you how you are going to use that in the form of equation. Since there is no horizontal loads, horizontal reaction at A and E, okay, should be the same. Okay, right. Now what next? Take one of the supports and work out for vertical reaction. You need vertical reactions now. So we have got some information on horizontal reactions. So that's over. Then what next? RAY or EY you have to solve. Okay, so how you do that? Take moment about E of all the forces. Sigma M about E is equal to 0. That you have to write now. So take moment about this E. Okay, M E sigma is equal to 0. So what do you write starting from here at A? So this H will pass through E, so moment is 0. RAY into the perpendicular distance is 14. RAY into 14. Next, that is clockwise. Remaining all are anti-clockwise due to loads. So 17 into 4 plus 3, 7 plus 3, 10. So 17 into 10. 10 into 7, 4 plus 3, the horizontal distance between 10 and E. Okay, so that is 10 into 7. One more 10 kilonewtons into distance is 4 is equal to 0. So this is sigma ME is equal to 0. So only one unknown here, RAY. So 280 divided by 14, 20 kilonewtons. Now by applying sigma Fy0, okay, you can get another vertical reaction, right? Sum of all vertical forces is equal to 0. So RAY plus REY minus 17 minus 10 minus 10. Okay, these three are downwards. and only these two are upwards. Total 5 vertical loads. How many are there? Total 5 vertical loads. So RAY, I write the equation here, plus REY minus 10 plus 10 plus 17, 37 is equal to 0. So already RAY you have solved, you have got 20. So what you need is just REY, that is 37 minus 20, 17. Okay. So reaction at A is more and reaction at E is less. Okay. Reason what? You can see more load is towards left, less load. Okay. How do you say that? Yes. To the left you can count 17 kilonewton. To the right there is only 10. 10 is at the middle. Middle 10 is on the middle, right? So to the left it is more. Okay, right. Now what? So you have got RAY value and REY value. Hmm? Right. Now to get the value of H, only we have concluded HA is equal to HE. Okay, not the value. So let's see how you get the value. So by taking moment about point C where you have known data, so you know this, okay? So that's why take a section here, okay, and take moments about either to the left or to the right of the section. Now you are taking a section, okay, right? So I am taking a section at C, and all the forces to the left of C take moments. So this is the section I am going to take. Sum of all moments to the left. So what you have? H into 2. Perpendicular distance for H is 2. Okay, so H into 2 anti-clockwise. Right? 17 into 3, this distance. 17 into 3, same direction, anti-clockwise. And then another one, RAY into 7. RAY into 7 clockwise. So that is this one. So RAY into 7 clockwise, H into 2 anti-clockwise, 17 into 3 anti-clockwise. So RAY is known to you. Substitute for RAY, get H value. So that is coming to be 44.5. Okay. So now we have got, you see, 4 unknown values you have solved. What are they? HA 44.5, HE also 44.5, and VA 20 and VE 17. Total 4 unknowns we have solved. Okay. So still how many are there? 6. Total 10 we have estimated, right? 4 tension values and 2 geometric values, YB, YD. Okay. So all these are to be estimated, right? So this is to start with what you need to do. Okay. So first to start with, you have to prove that HA, I mean horizontal reaction at the two supports is same. And then you have to take moment equation at one of the supports, then find out one vertical reaction, then take sigma Fy0, then solve for another vertical reaction. Then you take the moment about the point where the geometry is provided to you. Okay, so this is for this problem. how we proceed. Next, what? So take moment about B of all the forces to the left of B. Okay. So that means you take section now at B. Okay. Because in the previous case we don't know H value. That's why we must know this sag value. Now it is reverse. No? You know H value now and you don't know the sag value. So now you take section at B, sum of all moments to the left. So it's very simple. There are only two forces. RAY into 4 clockwise, H into YB anti-clockwise. That's all. You see that? So RAY into 4 minus H into YB is equal to 0. Substitute for RA 20. Substitute for H 44.5. You get YB value. That's what? 1.798 meters. Right. Same way for D. Right. Take a section at D. Sum of all moments to the right. To the right. So what do you write? R E Y into 4. So anti-clockwise, positive, minus clockwise, H into YD. H into YD is equal to 0. Why you are writing 0 even when you take a moment at section D? Because anywhere in the cable, bending moment is 0. You take any point on the cable, because cable has got only tension value. Shear is 0, bending moment is 0, right? So that's why you have taken a point on the cable, bending moment is 0 at that point. So now you know REY value and H value, substitute, get Y D value. Okay, so that is done here. So YD you are getting 1.528 meters. Okay, so more sag towards left, less sag towards right. That you see. Because what? Because of unsymmetry. So left you have more load, so sag is more. Right hand side from center, less load, less sag. This is 1.798, whereas YD 1.528. 528. Okay, so this point, the point D has come down lesser amount than the point B. So more the load, more the sag value. Okay, so that's done with the two more unknowns we have found, right? It was 4 earlier plus 2, 6 unknowns we have solved. So 4 reactions solved and 2 geometrical unknowns solved. Okay, then remaining 4 unknowns are there. What are they? Cable tension values. So tension in AB, TAB unknown value, TBC, TCD, TDE, like that. Okay, so 4 unknowns are still there. So that what to do now? As I said earlier, take equilibrium of each joint A. Okay, so let's try that. So write those H value. What is H value? 44.5. You write this value here. So this is 44.5 and this is 20, right? Vertical reaction is 20, horizontal reaction is 44.5 kilonewton. Right. So taking giant A free body diagram, you see that. So this is giant A. So you have H, you have V. So there is a cable here. So you cut this cable. Free body diagram means you have to remove the joint from the system, right? So you have to remove the joint. What to remove the joint? You have to cut this cable. So the reaction from the cable is like this: T A B. Okay. So in engineering mechanics, you might have studied that if there are only two forces acting on a body, if there are only two forces acting on a body, for the body to be in equilibrium, those two forces should be in acting along a line, same line. Means what? Collinear, equal and opposite. Got it? So you know this value, you can find the resultant of these two. That will act something like resultant. So now you can remove H, remove RAY, and only R is acting. Okay, so what happens now? There are only two forces at A. A is in equilibrium. So these two forces should be in the same direction, same value. So resultant value is equal to tension in AB. Okay, so how do you find resultant? This is like this. Square root of, so this is one way of doing, the other way of doing. Okay, I'll tell you both. Okay, so not to confuse you. So tension in AB may also be calculated like this: square root of RAY square plus H square. Finding resultant, that's all. You'll get the same result even in the other way also. Right. What is the other way? By components, that's it. Sigma Fy0, sigma Fx0, same equilibrium concept. So sigma Fx, so assuming that this is some theta, okay, right? So TAP cos theta is equal to H TAB cos theta is equal to H. TAB sin theta is equal to RAY. TAB sin theta is equal to RAY. Okay. Right. These two are the equations that you can form from sigma fx0, sigma fy0. Right. So from these two, you can find what is TAB and what is sin, what is theta. So even you can find theta also. So TAB and theta can be found from these two. But that is done here. Okay. So this is what is shown here, right? Either you can do that procedure, right? Equilibrium of A, or you can do the you using the force system concept, what you studied in engineering mechanics. Okay, so that's how you solve one unknown. Okay, from that you know uh, cable tension in segment 1. What about segment 2? Okay, BC, right? Okay, let's see that. So how do you find segment BC tension value? Okay, so just take this joint outside. I mean, it's a free body diagram. Okay, so what you do, and draw it separately. So let us draw that free body diagram. So first you draw one horizontal line and one vertical line so that they are reference axis. Then draw as it is whatever is there at joint. So there is 17 kilonewton load at B, and there is a cable TAB, right? Cable AB, right? That one, cable AB, and this cable is below this. You have drawn a line like this, right? So below this, TBC is below. TBC, right? So you know TAB value from the earlier joint. What is TAB value? 48.789. Write that one. 48.789. And you know this angle, theta. Okay, this angle is equal to this angle. Okay. So how do you know this angle? Either by geometry or by the other way, like from this equilibrium equations. So you use geometry. This is 4 meters and this height is 1.798. So just take tan theta, opposite side by adjacent side. Tan theta is 1.798 by 4. Theta is tan inverse. Okay, so theta AB, theta AB, tan inverse what, 1.798 divided by 4 will give you theta AB value. What is that one? Okay, so something. So they have just gone for here straight away by fractional values, not by the decimal value, right? So let's proceed further with that same notation. Okay, so TBC you want, and also theta BC you want. So you want theta BC value. Okay, this is 17. Okay, now you apply sigma fx 0. Okay, and also sigma fy 0. So first use sigma fy 0 so that you will get TBC and theta BC value, so that one unknown can be found out when you use sigma fy 0. So like that. So taking that into consideration, you can see it here. So sigma fx 0 is written like this. So TAB cos theta, this diagram as it is I have drawn it there. So TAB sigma fx 0, TAB cos theta AB is equal to TBC cos theta BC. So now what is TBC is equal to TAB means what? 44.5 into cos theta AB, that is 44.5. Cos theta BC is written like this. Okay, that is from geometry. How do you find theta BC? So draw a line like this. So what is this angle? Theta BC. This angle is theta BC. How do you get it? What is this height? Total is 2 minus 1.798. That is this height. What is this one? 3 meters. Right? So how do you, what do you want? What quantity you want on the equation? Cos theta you want. Okay? Right? So what is cos theta value then on this diagram? Cos theta means adjacent side by 3 meters by this hypotenuse, right? What is hypotenuse? Square root of 3 square plus this dimension 2 minus 1.798. What it is? 0.202. So 0.202 square. That's it. That is what is written here. Okay. So 3 divided by square root of 3 square plus 0.202 whole square. That will give you TBC value. Similarly, another joint. Joint C. Okay. How you get it? Joint C you can see here in the diagram. Joint C. If you draw a horizontal line at C, both the cables are above that line. That's why this diagram you got. This one. Okay. So TBC and TCD, both the arrows are upwards. Okay. Similarly, you have to work out TCD value from sigma fx 0 because you are not using sigma fy 0. Same concept here. So you can see finding theta CD is also in the same way. 3 divided by square root of 3 square plus this is the difference between those two sag values. Okay, so 2 minus 1.528. 2 minus 1.528 difference in sag values will give you theta CD value. Okay, that's how it is. So TCD is 45.05. So you are just using one equation because you want only one unknown. Right? Sigma fx 0 you are using always in all the equations because the angle that you are finding is from geometry. So this one you are finding it from geometry. That's why the tension value is the only one unknown required. That's why you are using one equation. Okay, got it. So TBC cos theta BC is equal to TCD cos theta CD. That is the equation here. Similarly, the other one, right? Joint D. Then joint D also, you can draw free body diagram from joint D. Then joint E. Okay, right. So DE once cable tension DE is known, either you can use joint D for this or directly E you can take. The same concept that is applied at A can be applied here. Okay, so it's something like this. See, there is a horizontal force, there is a vertical force. So there is a cable here. So resultant of these two shall be along this direction resultant, and the value should be same. So T DE or ED both are same shall be equal to the resultant of these two. Means what? H square root of H square and R E Y square. Okay, that is R, and that is equal to TDE. Okay, so that is how you have to solve this one. So TDE value I worked out from both. You can see it here, square root of 17 square plus H is 44.5, this one, and also from the equilibrium. Both are same. Okay, so either you can use this concept or equilibrium concept. Okay, so that is how all the tension values are being solved. You can see now the tension value in AB is 48.789 tension in BC is 44.6 and tension in CD is 45.05. Tension in D is again 47.636. So the cables which are at the ends are having a higher value of the cable tension, and that too AB portion is having the maximum value. Portion AB tension value is maximum. Okay, so practice this problem uh, many number of times until you are able to solve this on your own, right? Thank you.